For watching. I'm working more today on my stock market tool. Today is April 4th, 2026. If you're interested in the stock market, Python coding, AI coding, um, machine learning, markets in general, subscribe because I work on this every day. So before I get down to business, I'm going to go over the general goals for this project here. So I have two goals. First goal is to beat the S&P 500 and make money in all regimes. So if the S&P 500 is going up, I want to do better than it by a significant margin, 2 to 3 times. If the S&P 500 is going down, I want to still reliably be making money. Now I'm writing all of this in Python code, so I have a second goal for this, which is I'm generalizing the code to make a usable tool that anyone can use. So I'm not releasing the model that I'm making, but I will be releasing the code I'm using to make the model. And in under 50 lines of code, you can create a universe, create features for your universe, feed it into a model, and generate a model. So this is kind of the strategy I'm using here. So I have data. You don't want to use all data. So I'm starting with data and then trimming it down to a universe of stocks. An example of a stock universe would be maybe, for instance, the S&P 500. If you can find out a way to get that data, it's kind of hard to get for historic data. Um, but you basically don't want to include things like penny stocks or stocks that are trading with low volume. Penny stocks, because their price dynamics are different to normal stocks. And also, you don't want to have low volume stocks because there's going to be a lot of slippage. There's a big gap in the bid-ask spread. Whereas if you have really high volume stock, that gap's going to be closed to almost nothing. Once I have a good universe, I'm now using this to train a returns model. Basically, this should be predicting return for the stock, probability of a positive return, return relative to the market average, stuff like that. Once I have a good returns model, I'm going to be feeding it into this portfolio model, which is looking at macro market features, things like, what are the interest rates, how is the market average performing, and then it's going to take the output of this returns model and decide how to allocate a portfolio based on that. So I started this at the beginning of the year. This is where I was in January. Basically, I made a model. I did find portfolio strategies which worked to beat the S&P 500, but these strategies were really fragile. I needed to go through and iterate through a bunch of different features and targets in order to get a model that worked. Before I could do that, I had to reorganize the code base, so that's what I did here. I added all of these features and targets, and I changed it so that basically I'm putting data and filters into a universe. New filters are easy to add. They're really flexibly defined, so I can try all sorts of different things. The model is also flexibly defined. It's a Python class. And then I made feature and target classes. And all I have to do is just pass them into the model, and the model will calculate the features itself and then train based on these features and the target that you specify. These are all the features and targets I added. Once I had that, it was time to go through and find a model. So I found initially a model that was pretty good here. I thought this is working well. I did all sorts of tests, and after the tests, which I finished a few weeks ago, I was really confident. I added all sorts of things to make sure it wasn't overfitting, etc. And by the time this was done, I was really confident in the model. You see here my conclusion is that model is robust. The problem is when I did a walk forward analysis, I saw that the performance was falling off with time. So I've been trying to improve this the last 2 weeks. And before I could improve it, I ran into all sorts of other problems. I won't go through those because it's not too interesting. The main problem with how this is going is there are kind of two main problems. The first main problem is that I was including all stocks in my universe, including things like NASDAQ test tickers, which never change in price. And so that was artificially inflating the performance of the model because I'm trying to predict on things that are well known. The other thing was that when I'm calculating the features, it was calculating the features from the model. So, for instance, if 60-day moving average is a feature for the model, um, that was being calculated for the universe. So each month the universe is generated. And so there are stocks coming into the universe and being dropped out of the universe. So, for example, if you imagine Apple was in the universe in January, got dropped out in February, and then was put back in March, and I'm trying to get the 60-day moving average, that's going to get the moving average over March and January, and not February. And so that's going to have a big, spike in the data, and that's not going to really be a good feature. So there were some other problems, but those are the main ones. So I finally finished fixing that yesterday. And so these are the results now on Model 12. Um, uh, so that looks, it's not perfect, but it's a lot better. Big problem here is you see the information coefficient goes negative in 2025, so I need to look into that. The information coefficient should be above 0.01 and ideally above 0.02 for every year in the walk forward analysis. So I did the walk forward analysis on a different model. It's basically Model 18. This is basically the same as Model 12, but I added in sector neutralized features for volatility and mean reversion features. And you see this seems like it's performing better, but it's still not perfect. So today I'm going to be looking through to see if there's anything I can do to further improve the performance of this model. Before I get to that, I kind of need to finish documenting this. So let me put these guys in, make them the same size. Yeah, so that's what I'm working on today, is improving the model. Basically, I want to get an information coefficient above 0.01 for every year. So Model 18 is not performing any better. So in Model 18, do I have ADX? Not adding ADX regime there. ADX. Let's see, do we call ADX somewhere? Oh, ADX is fine, but we don't want beta. So back to test Model 18. So let's add a new question here. Does Model 12 perform better with 5-day, 20-day? I think it's in, what are the time windows I'm using? So let's go to test Model 18. 5-day, 20-day, 60-day, no 200-day. 5-day, 20-day, 60-day, and 60-day beta. Let's see here. Does removing neutralization on MA crossover improve results on Model 12? It did not. Okay, so these are the good results for Model 12. So let's put this in here. And what happened? The sector neutralized model 18. Is performing way worse. So I need to see, is there a problem in the sector neutralization of the feature engine? Okay, so I'm going to take my jacket off. It's too warm. All right, so let me put some music in, and then I'm going to get down to business. All right, so Model 12 versus Model 18 versus Model 12 walk forward analysis. So that's kind of interesting. Model 18 looks like it does way better there, but it's doing better on the walk forward. Sorry, Model 18 is doing worse on the single model, but it does better on walk forward. So I'm going to look at this. Now let's copy this slide. Does Model 12 perform better with 22-day forward target? So instead of Model 12 without beta, Model 12 with 5-day target. Model 12 with 22-day target. And then all we have to do here, let's go to test Model 12. So, yeah, the target neutralized to the market should perform better. So let's save this and go up and turn Model 12 back on. So I want to see, I'm going to add fundamental features, but that's going to be a pretty strenuous thing to go through. So before I do that, I'm going to see, can I just add, is there any tweaks I can make to the model which will make it perform better? Sorry, I need to get something good to listen to. There's nothing good to listen to. Yeah, man. Okay, I'll listen to Adele. Where's my phone so fucked up? All right, let's run Model Explorer again, then let's go document this stuff. Let's go to desktop, work, stock market tool, data, models, now model 12 walk forward, quick look. Let's put it in. Why did 2025 do so poorly? Oh shit. I want to turn model 12 on. Oh, turn that guy off. So did I save this? All right, now let's put this in. Model 12. Model 18 walk forward. Looks much better. Wow, so 2021 this had almost 54% directional accuracy. 22 it was still really good and then it fell off. But the information coefficient was really good in 24. Bad in 25. But, you know, 25 had the tariff crash. How are you going to account for that? Okay, so while this is running, I'm going to go back to looking at my physics idea. I want to do laser Doppler velocimetry for basically vibration tools. Okay, so let's start a new PowerPoint for that. Okay, new slide. So let's put the date for 2026. Okay, so widely used in shock physics. It also has applications for vibration monitoring. What do I call that? Use telecom poles. TOSA. Okay, we need to get back to the overview. Give me the applications are civil engineering, remote biological monitoring, and vibration monitoring in industrial machines. Is there anything else? Alright, it's not improving the trials aren't improving. One trial improved the parameters. That's kind of odd. So it's at 35. Once there's another one. Alright, so once this runs, we'll get a good idea of if longer time horizon. So we have these models. I guess they're performing all right. Here, model 12 worked well on the data split I'm using. Maybe I could do some ensemble. The problem with ensemble models is they get complicated. I'm kind of lost on exactly how to do it. Remote biological monitoring. Yeah, so am I missing anything here? So let's search that term on eBay. All right, here's the model output. So most important is regime. 200-day regime. I thought I was dropping that out. But you know, that's not going to be good if I drop out my most important metric. Okay, let me go back to model 12. Are you going to bed? Nighty night.
I thought you were talking to somebody.
No, Austin called me earlier.
Oh, what's he have to say?
Oh buddy, what, he's saying Michaela's getting married.
Oh yeah, when is she getting married? I know she's at.
And then he says, you and Drew are invited. And I said, okay, well, I'll wait to see if she invites me to.
Yeah. Awesome.
Anyway.
Alright, Betty's out here. I'll see you in the morning.
Okay, nighty night, love ya. See you tomorrow. So basically the idea for the laser Doppler velocimetry thing is I do that at work. At work, we have shock physics experiments. I'm shooting a laser at a surface, and the idea is that you're picking up really fast velocities. You're picking up like things from 20 meters per second up to thousands of meters per second. And you're capturing them on nanosecond timescales. So you can, it's just Doppler shift. Like when an ambulance goes by you, when the ambulance is coming towards you, the sound waves from the sirens are getting compressed, so the sound waves you hear are shorter than the ones being emitted from the siren. And then when the ambulance goes past you, the sound waves are, whatever you call it, extended or whatever the term would be. Basically the ones you're hearing are longer than the ones being emitted from the ambulance. So then, the effect of that is it makes the noise sort of like that. And so you can do basically the same thing with lasers, see how the wave's being shifted, and you could get the velocity of something. So this is something I already do and I'm used to. And they're doing it on civil infrastructure like bridges. You want to monitor how things are vibrating. Same thing with industrial machines. And the idea is you can basically, instead of having to have a sensor on the thing, you want to move it far away, have it be remote, and monitor it, either from a safe area or from a distance. So the current things they have to do that cost like $30,000 or $40,000. So if I could build one for $5,000, that's a company. So, so here I tried moving 22-day forward target, but I'm not getting enough data in feature engine. So let's go back to feature engine. Let's see where we're getting data. So feature engine, buffer days forward, max forward is max of the shift. Oh, so this is working. Okay, so never mind. I thought 22 days. Hey, Moonlight. I'm good, thanks. How are you? I went golfing today. That's why I'm wearing this shirt. So I had a good day, but boy, golfing really wears you out. It's 4 hours of being outside. It's pretty physical. It doesn't seem physical, but when you're playing golf, it is very physical. And especially the way I play. Some people don't play. Some people it's not as physical for them, but I try to keep my abs tight on every swing. And so by the end, I'm pretty exhausted. So it does pretty poorly. I need to figure out why. So let's go back to Model 12. Test Model 12. What the hell's going on here? Model Explorer. Uh, 520, 60, 200. ADX regime. Oh, so I was probably falsely inflating the performance. Oh, Model 12. Wait a second. Oh, so that's with the ADX regime in there. So probably this looks artificially good because it's excluding data from like 25. All right, so let's go to test walk forward. This is confusing. Did I only do this for Model 18? 18. ADX regime, is it in here? What is going on? Did I not save these changes? All right, so let's run diagnostic 3. All right, so back to this. The stock market tool, well, it's basically working. The problem is let's look at this. Yeah, 200-day. Good. So that's the same. I just need to take this stuff back out. The tool's working really well. I mean, I might find more bugs in it, but I've basically just been troubleshooting bugs. But I think it works. The problem is it's only using price data. So that's going to make it a pretty simple model, and it's really kind of really not even to bare bones for quants yet. Bare bone quant model is basically all technical indicators as features. So price data, but they also have fundamental data. So everything from fundamental data. Um, so, what's the result of that? Basically, I need to add fundamental data into the model to get it to the bare bones stuff. But the model is not performing well. But the stock market tool, I don't know if that's that interesting of a tool, but you can make a model that trains on any price features. So the tool's good, the models aren't good. But here the problem is ADX regimes getting included. So let's go back up to test model 12. And I guess model 12 walk forward, that shouldn't have ADX regime, right? I am including it. Wait, let's look at this diagnostic really quick. Because what if I just change it to be, instead of 200-day moving average, if I use 150-day moving average, is that better? Industrial machine maintenance, bridge monitoring, power grid transformers. Transient event market, end of line factory quality control. That drops it, but it's still failing. So what if we do 100? How does it work? Reflector setup. The bare diode. Okay, so you could get one of those guys for pretty cheap. Not that cheap actually, but let's see. So what if I look for that guy? Current adjustable from 500 to 1000 milliamps. It's expensive. Alright, so how's that go? Okay, Panda's beta. So I can drop beta and use ADX regime. Let's try that on Model 12. So Model Explorer, Model 12, change that to 100. I don't think I have beta in here. Let's go back and add the ADX regime back in. Good. Change this to 100 and then beta. I'm not adding. Oh, that's the diagnostic. So instead, let's do Model Explorer. Check one more time. Yep, that's 100. So what if I use 100 days as the long term? The problem is you need something to reflect off of. DFB laser. Okay, so the Model 12 is running. For $200 on, no, $800. Confirm this will work and assess the total cost for each item required. What is the cheapest oscilloscope I can buy which will suit this application. What is this? Come on. But if you just rip the CSV data directly into Python, okay. So let me look up this guy. Let's see, is the model running or is it done? Trial 7. So I think it's taking longer. Actually, this is a good indicator because before Model 12 wasn't working because ADX regime was dropping a bunch of data. And then you saw I was running a bunch of iterations, but it wasn't improving at all. Where is that? Yeah, so look, that was improving. Yeah, I'm not sure where it is, but it wasn't improving earlier in the stream. So this is good. It should be improving. Laser. That's not going to be $200. Splitter. Mixer. Oops. Yeah, I don't know. I feel stuck on that. trial 24. So this is going through, running. Yeah, it's taking a long time though because there's a lot of data. Splitter, coupler. So I can get the oscilloscope. Oh, for not that cheap. Here we go, that's what I want. Okay, how does that compare to the cost of Tektronix? Whoa, $10,000. That's a nice one though. Over $1,000. Yeah, that's not bad. It's not bad at all. So I might just get a Tektronix. Okay, so 3x3 single mode fiber coupler. One by two fiber couplers. Why do I need a 1x3 fiber coupler? Fiber splitter. Coupler. To get heterodyne. Won't a 1x2 work? Okay, the model finished. Here are the results. 100-day regime is most important. 60-day regime, second most important. ATR 100 days, moving it. So all the regime features are most important, so that's good. Point, whoa, 0.0276. 0.1, 0.2639. Oh, but this is on 30 days. So 22-day forward target on model 12 with 160 what is it? 160, 20, and 5. So that looks really good. Let's put this guy in, and then let's do the same for model 18. Okay, so that looks good. Now let's go to model 18. Change that to 100. And then I don't think I'm including beta. Yep, so let's see how this works. Oh, let's do a 30-day target. So target, time period, not 5. Let's do 22. And let's turn model 18 on. Turn model 12 off. Let's see how this performs. Okay, so this is the most important physics question. I've reached my limit. Okay, I'm pretty tired to be honest, so I'm gonna end the stream. I'll give the results on this model 18. But that's it for tonight. Thanks for watching. Have a good rest of your night. Adios.